A regular hexagon and a regular pentagon are joined as shown. Complete the table below with the values of x and y. Justify your answer using geometric properties. We need to basically find the value of x and y, right? Now, how do we figure this out? Now, this is 6 sides. Regular means all 6 are of equal length. So, what is the angle in each internal angle? Well, sum of angles for hexagon. Let's work with hexagon first. Now, for hexagon, sum of interior angles is equal to 180 degrees times, the formula is n minus 2. N is 6, right? Hexagon means n equals to 2. So we get 180 times, 6, n is 6. We get 6 minus 2. So that is sum of interior angles, right? So we get this value as 180 times 4, correct? So that is sum of interior angles. So each angle is how much? We have 6 of these, right? So each interior angle will be equal to 180 times 4 divided by 6, correct? Since there are 6 of these, right? There are 6 of these. All are equal to x, clear? So when you divide by 6, you can simplify. 6 goes 3 times in 80, so it is 30. And 30 times 4 gives you 4 times 3 is 12. So we get x equals to 120 degrees, right? So each angle here is 120 degrees. Does it make sense to you? So we can write here that the value of x is 120 degrees. Justification I'm going to give here, right? Now let's look into the pentagon, but we'll do the same calculations. So here n equals to 5. So sum of angles is 180 degrees times 5 minus 2, which is 180 degrees times 3. Now, how much is each angle, right? So let's call this as z. So each angle z will be 180 degrees times 3 divided by 5, since we have 5 of them in pentagon, right? So let's simplify this. 5 goes 5 times 3 is 15, and 5 times 6 is 30. So we get this value of z as equals to 36 times 3, which is 6 times 3 is 18, 8, 108 degrees. So each is 8 degrees. So this is also 108 degrees. Do you see that? Now, what is the value of y? Now we know that at this point, full circle is 360 degrees, right? So total is 360 degrees, correct? Therefore, y should be equals to 360 degrees minus 120 degrees minus 108 degrees. Is that clear to you, right? So that is how we are going to answer this question. Perfect. You're allowed the calculator, so you could use calculator. I prefer to do without calculators, however. And then we'll write down our answer, which is 132 degrees, correct? So the value of y is 132 degrees, which we can write here, 132 degrees. So I hope the steps are absolutely clear. Let's go through them once again. We found the internal angle for each. For a hexagon, each angle is 120. For a pentagon, it is 108. For a circle, this is a circle, right? It is 360 degrees, about a point. So total should be 360. Y is 360 minus 120 minus 108, which gives you 132. So that is how we are going to solve this, right? So let's take the next question. So we are done with the open response questions. Now again, multiple choice question number 15. It says the information about 4 different linear relationships between C and N is shown. The question is, how many of the linear relationships have rate of change of 5? So this definitely is constant, it is 0 here. And in this case, if I take a point and make this triangle, we are going up by 15, dividing by 6, it is not 5. Now let's look into these tables. So we have here 35 minus 30 divided by 12 minus 10, which is 5 divided by 2. It is not 5, right? And here we have, let's do it in a different thing. We have 90 minus 50 divided by 8 minus 0, which is 40 divided by 8, which is 5. So this is correct. So we have only one, which is this one, which gives you the rate of change of 5. So the correct option is D. Is that clear to you? So that's how we will do it, right? Let's take the next question, which is question number 16. Which graph shows a line that is perpendicular to the line 4 over 3x minus 4? So that means perpendicular means negative reciprocal. So we need a negative 3 over 4. So line has to go in this direction, right? While this cannot be case, this, let us see. 1, 2, 3, this goes 4 down, so that is not the case. But here we have the right solution. We are going down by 3. 1, 2, and 3, that's correct. And we are here 1, 2, 3, 4. So this is correct. So option B is the right option. Perfect. So that is how you're going to solve it. Now, question number 17, again based on lines. So we have many questions based on linear equations. You have to master this technique, right? What is the equation of a line perpendicular to the line represented by this? So again, we have slope, which should be 2 over 3 this time. Negative reciprocal, right? So we have 2 over 3 here, right? So that should be perfectly fine. Negative becomes positive, right? So that is, so it says, what is an equation of a line perpendicular to the line represented by this, and we have another condition, with same y-intercept as the line this. So we need y-intercept of 7, right? So which is also there. So we match both the conditions, so A is correct. This is also 2 over 3, but not 7, right? That is why this is not correct. A is the right option. Clear? Question number 18. The total cost to repair a fridge C in dollars can be represented by the equation C equals to 60t plus 30, right? That means 30 is fixed cost and the rate is 60, where t is the repair time in hours. Which of the following statement is true about this relationship? The hourly rate is 90, no, it is 60. The fixed fee is 90, no, nothing to do with 90. Hourly rate is 60, okay. And the fixed fee is 30, perfect. So that is correct option. Here is question number 19. What is the area of the shape represented below? So we want to find this area. Do you understand? We want to find this area. So I hope this part is absolutely clear. So you can think about two triangles in this case, right? And solve the question. Perfect. Now what is the area of a triangle? So area of a triangle is half of base times height. Now in this case, base is constant, right? So base B is 14 centimeters. And we have two different heights here. So for the first triangle, which is the smaller one, we have height of 8 centimeters. And for the bigger one, let me use a different ink, which is right there. We have a height of 12 plus 8, which is 20 centimeters. Do you see that? So this height here is 20 centimeters. You have to add them up, right? Now, we need to find area of this shaded portion. So we can take away area of one triangle from the other, right? So what we get here is area of the big triangle, let's say this one, will be how much? Let's do the calculations on the side here. So big triangle will be half of base is 14 times 20. From this, we have to take half of base is 14 and the height is 8, right? So that is what we have to do. So we have 7 times 20, take away 7 times 8 to get our answer, right? So we could take 7 common, 20 minus 8, which is 12. So 7 times 12, which is 84, right? So 84 is option C, which is the correct option, right? You could do 140 minus 56 also, right? At this stage, you could do 140 minus 56, which is also 84, either way. So you get the answer, which is 84 centimeters squares. Clear? So I'd like you to go through these questions once again, see how on the left side we worked on the linear equations and on the right side measurements, geometry. The more of geometry, right? So we have many difficult questions based on geometry, always in EQAO. Let's look into question number 20. This diagram shows a green house that is built in the shape of half cylinder, right? Half cylinder. Material to cover the roof costs $3 per meter square. The shaded ends will not be covered. So this is not covered. So only lateral areas. We are looking for lateral area, that to divide by 2 of cylinder, because that is half the cylinder, right? And the cost is 3 meters square. So we'll multiply this by 3 to get our answer. Is that clear to you? So let's figure out this answer. So what we get here is the circumference is 2 pi r and this length is 80, but we are going to use half of it, right? So pi r. So we have pi, we can write 2 pi r times height divided by 2, since we have only half of the cylinder, right? So in our case, r is how much? R is 10, radius is 10, not 20. So we have 2 and 2 cancel, we get pi times 10 times 80, correct? Or 800 pi, which is 3.14. We'll use the calculator, find the exact value. So we have 800 times 3.14. So more than 2400. So we get 2512. 2512. Now this is area in meters square, correct? Now what we really need is the cost, right? So materials to cover roof with the cost of $3 per meter square. So we need to find which are the closest to the cost of covering. So we have to multiply this by 3. So let's multiply this by 3. So we have times 3 equals to 7536. So we get this as 7536, correct? So that becomes the answer. 7536 is close to A, which is 7540. So A is the right answer. Is that clear to you? Slightly difficult question. I'd like you to understand the concept. Go through the surface area of cylinder formula and understand. Is that okay? Now let's look into the second question, which is question number 21. We're almost at the end now. It says a cone is pictured below. This is a cone. Use Pythagorean theorem. That's a hint. Which of the following is closest to the surface area of the cone, right? So here we have two surfaces. One is this surface, which is pi r square, right? So we can write this as 3.14 times r is 5, not 10, half of 10, right? So we know here that r is 10 divided by 2, which is 5. So that is this area, pi r square. The other area is the curved area of the cone, right? So we have to find this area now. Now this curved area is pi r L. Now how do we find L? L is this length. To find L, we'll use Pythagorean theorem. So that is the hint for you. Is that clear? So let's use the Pythagorean theorem to find L. So we know in this case, this is 5, the height is 12. So L square is equal to 5 square plus 12 square. Or L square is equals to 25 plus 144. So L square is 169. L is square root of 169, which is, 13. So we know L is 13. Therefore, the curved area is 3.14 times the radius, which is 5 times 13. Is it okay? So that is the curved area. Right? Which we are using this formula, pi r L. So let's use the formula and find the answer. 3.14 times 5 times 13, which is in decimals equal to 204.1. Correct? So we have two areas to add. One which is equal to this one, 314, and the other one is this one, right? Let's calculate the 314 area also. 3.14 times 5 square, which is 25, in decimals is 78.5, right? So we'll add these two. So we get 78.5 plus we have 204.1. So we get 6, 8 and 4, 12, 8, 282. So we have 282.6. So B is the right option, which is 283 centimeters square. Is that clear to you? So that is how we are going to do. So basically, we have to add the area of the circle and the lateral area, correct? Both the areas. So this is our area 1, this is area 2. When you add them up, you get your answer. Perfect. So have a good look at these questions. They are very good questions and they're expected to be repeated. So go through them. Last question here is question number 22. Now after this question, I'll actually add 3 more questions which I discussed with you earlier. They are expected in the coming test papers. Let's first finish off with question 22. Which of the following composite shapes has 900 degrees as the sum of interior angles? Which of the following composite shapes has 900 degrees as sum of its interior angles? We are given 4 different choices here. Let us see how to answer this question. If you notice, we have kind of a square in each one of them. So if you look at the square itself, it gives you 4 right angles here. That means we already have 360 degrees for each, right? So that means 360 degrees for the square part, right? Now, what we could do is that from 900 degrees, we can take away 360 degrees. So we are left with, from 10, if you take 6, it will be 4. And from 8, when you take 3, it will be 5. So 540 degrees should be the angle for the polygon, right? So the other polygon, so plus polygon angle should be equal to 540. Now we know the formula that 180 degrees times n minus 2 is sum of angles. Correct? In our case, we want this sum of angle to be 540. So we can solve for n n minus 2 should be 540 divided by 180. That goes 3 times. So n should be equal to 3 plus 2, which is 5. So we are looking for a pentagon. Now this has 4 sides, 1, 2, 3, 4. Here we have 1, 2, 3, 4, 5 sides. So this is a pentagon. So that becomes our solution. Is that clear? And here, which is relatively simple composite area, which we'll discuss, and then I'll provide you a solution with a very important question, which is right there. It says the field inside a 400-meter running track is to be seeded. Each straight portion, that means from here to here, of the track is 100 meters. Each curved part of the track is a semicircle. 1.5 kg bag of grass seed will seed an area of 80 meters square, and you have to answer all these questions, including the cost of seeding the whole area. Perfect. I'd like you to pause the video, copy this question, answer, and then look into my suggestions. So that could be in your test now. The question here is, the field inside a 400-meter running track is to be seeded. Each straight portion of the track is 100 meters. Each curved part of the track is a semicircle. 1.5 kg bag of grass seed will seed an area of 80 meters square. Based on this information, we have 5 questions to answer. A. What is the length of the curved part of the track? B. Calculate the width of the field. C. Calculate the area of the field. D. Determine the number of bags of seed required. E. 1.5 kg bag of grass seed costs $12.64. How much does it cost to seed the field? Now this is a very popular question at many test papers. I hope its solution will help many. Feel free to pause the video, answer the question, and then look into my suggestions. Now let's try to understand. We are given a field inside 400-meter running track. That means the perimeter is 400 meters, right? So we know that the perimeter of this field is equal to 400 meters. Now each straight portion of the track is 100 meters. That means this is the straight portion, which is 100 meters. So we have these straight portions which are 100 meters each. Now we need to find what is the length of the curved portion. So there are 2 curved portions, they form a circle, right? So length of curved portion will be $400. Take away 2 times 200, right? 2 times, let me write 100 here. So that gives you 200. So the curved surface is 200. So we get the first answer. What is the length of the curved part of the track? So it is 200 meters. Part B is calculate the width of the field. So let W be the width. Now, since we know that the circumference is how much? The circumference for a circle is 2 pi r, right? And that should be equal to 200. That means the radius in this case will be equal to 200 divided by 2 pi. We can calculate this. We're saying for this circle, radius r, right? So that is the radius r. So let's calculate the radius of this circle. So we'll divide 200 by 2, and then we'll divide it by pi. We'll take value as 3.14. So in decimals, we get 31.85. Okay, so we'll round it to 31.85 meters. So that becomes the radius. We need to find the width. So width W is 2 times radius, let me write 2 times radius, so which will be 2 times 31.85. So let's multiply this by 2 to get our answer in decimals, which is 63.7. Right, so this width is equals to 63.7 meters. Now part C here is to calculate the area of the field. So we got all these dimensions. Let's work on the area and the cost of the seed in a fresh page, right? So I hope you have understood all these concepts. Area you can find as area of the rectangle plus the circle, and we'll do it on the next page. So let me write down what we have found here. We found that the width is equal to 63.7, radius R is half of this, which is 31.85, right? So, and this portion is 100 meters. The straight portion for this track of 400 meters, right? So this is all we calculated already. Now let's calculate the area of the field. So the area of the field will be area of the rectangle plus the area of a circle, right? So area equals to area of rectangle plus area of circle. So area of rectangle in this case is 100 times the width, which is 63.7, plus area of the circle is pi r square, which is 31.85 whole square, correct? So we can calculate this area now. So we have 100 times 63.7 plus 3.14 times 31.85 square, which sorry, something wrong. Okay, so let's calculate this area now, which is 100 times 63.7 plus pi r square, so pi is 3.14 within brackets 31.85 square, and that gives you area of 9555.28 meters square, right? So we get 9555 meters square as the area of the circle, right? So we found the area as equal to 9555 meters square, right? Now determine the number of bags of the seed required. Now we are also given the information that 1.5 kg bag of grass seed will seed area of 80 meters square, right? So we'll use this information to find the number of bags required. So one bag, so forget about 1.5 kg, one bag will seed 80 meters square. So number of bags will be how many? So area divided by 80. So we have 9555, that is the area, divided by 80 will give you the number of bags. So let's divide this by 80, and we'll take a whole number, which is 1. When we write 119.4, you cannot buy half of a bag, right? So you need to round it to a whole number. So that is going to be equal to 120, right? So 120 bags. Is that clear to you, right? So you cannot buy half of a bag. That is going to be the number of bags. So to find the number of bags, we divided area by 80. and got our answer as 120 bags. Part E is 1.5 kg bag of grass seed will cost $12.64. How much does it cost to seed the field? So we need to multiply now the number of bags with the cost of each bag. So we get this as 120 times 12.64, right? Let's figure this out. We have 120 times 12.64, which is equal to, in decimals, in dollars, 1516.80. So that becomes the cost of seeding the area of this running track whose perimeter is 400 meters, right? So that is how we are going to answer this particular question. So I hope all the steps are absolutely clear. So let's go through this solution once again. In short, what we did was, we know that this straight line is 100 meters on both sides. 100 is 200. So the circle circumference, two semicircles make one circle, right? So we have two semicircles here which make one full circle, right? So that circumference is 2 pi r, which is 200 meters. Dividing 200 by 2 pi, we got our radius, right? That radius times 2 is the width. So we got the width. To calculate the area, we calculated area of the rectangle, right? And the circle. So we added the area of rectangle and the circle in this page, right? So we got the area of rectangle and the circle. Once you get the area, since we know that the one bag can seed 80 meters square, then dividing by 80 gives you number of bags. You need to round them higher, right? You cannot buy the bags in fractions. And multiplying this by the cost of each bag, you get the total cost for seeding. So I hope that makes sense. In this particular question, we have a composite figure. We have a trapezoid in which there is a semicircle. So semicircle has been taken away. The question here is, calculate area of the shaded region in the isosceles trapezoid with a semicircle as shown in the figure below. You can always pause the video, answer this question, and then look into my suggestions. Now, two formulas which you need to remember to find the area is area of a circle is pi r square, and area of trapezoid is E plus B times height over 2, where A and B are lengths of the parallel sides. So if we have a trapezoid, it may be isosceles, it may not be isosceles. So A and B are these two sides which are parallel basically, and height is the distance between them. Then that becomes the area of the trapezoid. Knowing this, it should be simple enough to calculate the area of the shaded portion. I would like you to pause the video now, calculate the answer, and then look into my suggestions. Now, to find the area very clearly, we have to find the area of the trapezoid and take away area of semicircle, right? So we have area of shaded portion as equal to area of trapezoid minus area of semicircle. Correct? So area of trapezoid, how do we figure this out? We need to still find the height. So first exercise is to find the height. Now how do we find height? So since this is like isosceles, these two sides are equal, so there is symmetry in this, right? So that could be the radius of this circle. We are given 8 centimeters. So these two sides are equal. That means this is 4 and that is also 4. That means the radius is equal to 4. So in our case, we can write that AB, as we are saying here, we can say A equals to 8, B equals to 14, and H equals to 4. So we get the area for trapezoid, and we know the radius R is also equal to 4. So using these, we can always find the area of the portion. Correct? So let's use these values. So area of the trapezoid in this case is going to be, we'll use this formula. So 8 plus 14 times 4 divided by 2, right? So we have used this particular formula, A plus B times height divided by 2, minus area of semicircle. Semicircle means pi times r square, r is 4, divide by 2. Semicircle means half circle. So we have to divide the circle area by 2, right? So that is to say that area of circle is this much. So area of semicircle equals to pi r square divided by 2. So we did this here, correct? So that is how you're going to find it. Now we can just calculate the answer, right? So if you do simple calculations here, we get 8 plus 4 as 12 to 1. So 8 plus 14 is 22. We are going to multiply this by 2. And then pi r square, 14 square is 16 divided by 2 is 8 minus 8 pi. So that gives you the answer. And the units will be centimeters square. Is it clear to you? Let's use calculator. So we have 22 times 2 minus 8 times 3.14, and the answer in decimals is 18.88 centimeters square. We can say approximately 19 centimeters square. Is it clear? In this video, we will derive a formula to find area of regular polygon. We'll take up two examples, one to find area of hexagon and the other one to find area of octagon. I'll provide you links for calculating the area using alternate methods. We'll also have in this series area of irregular polygons. So let's begin by understanding a very important term which is called apothem. Now, apothem of a polygon is the distance from the center. So this is the center of the polygon. Let's call this as O. To any side of the polygon. So this is the side of the polygon S. So this distance A from O to this side, so the shortest distance, is apothem. So the apothem of a polygon is a distance from the center of any side to any side of a polygon and is also the height of the triangle between the center and the two consecutive vertices. So if you're looking into these two as consecutive vertices, then a triangle is formed joining the center and these two consecutive vertices. So apothem A is also the height of this triangle, right? So that is how we actually define this term. Now, since you can see that if we have a regular polygon with n sides, so if we have n sided regular polygon, then we have n triangles. Correct? So in this case, we have 8 sides. It's an octagon shown before you. So there are 8 triangles. 1, 2, 3, 4, 5, 6, 7, 8. Correct? So there are 8 triangles. So now, area of polygon is equal to number of triangles, which is n in our case, times area of each triangle. Right? So since there are n triangles, we'll add them all to get the total area of a polygon. Clear? Now, when we talk about area of a triangle, basically it is half of area of a triangle is what? It is half of base. In this case, if S is the side length, right? So times height A, right? Times height A. So that becomes the area of the triangle, where S is the side length, right? So S is the side length and A is the height of a triangle, as you've seen here. Perfect. Now, you could simplify this and write this as, so I prefer to write this as answer A and S. A and S over 2, half of the answer, where A is the apothem length, N is the number of sides, and S is side length, each side length, half of that, right? So that gives you the area of polygon. Now, if there are n sides, in that case, n sides into the side length will give you the perimeter, right? So we could also write this as A times perimeter over 2, where P is basically the perimeter, right? So P is perimeter, right, which is sum of all sides. So if there are n sides, n into S is perimeter. Is that clear to you? So area of any regular polygon can be written as apothem times perimeter divided by 2, or apothem times number of sides, side length divided by 2. So that becomes a standard formula which can be utilized to find area of a polygon, right? So basically, area of regular polygon equals to half of apothem times perimeter. Is that clear to you? So that is a standard formula which you can always use and find area of a regular polygon. Perfect. Now let's take two examples. Here is your first example. We already know what apothem is. It is the distance from the center to any side, right? So this is the apothem. In this particular case, we are given octagon. That means n equals to 8, right? And in this case, we are given the value of A, apothem, as 24.75, and side length of each side is 20.5. So what is the area of polygon? Will be answer, right? We'll write A and S divided by 2. Easy to remember, right? So just multiply these three terms. So we get what? We get 24.75 times number of side 8 times side length, which is 20.50, or you can write 5 divided by 2. Units. Since we are not given any unit here, we will write unit square. Right. Is that okay? So let's do the calculation now. So we have 24.75 times 8 times 20.50, and we are going to divide this by 2 to write our answer in decimals as equal to 29.5 unit square. Is that clear? So that is how you are going to find the area of a polygon. Easy, right? Now let's take another example. So in these examples, I've given you the apothem and side length. Now in this case, the question is, find area of a regular hexagon with side length of 20 centimeters. So we are given side length of 20 centimeters and apothem of 10 square root 3. Now we're talking about hexagon. Hexagon means six-sided. So we know n is equal to 6. Correct? So now you can actually pause the video, calculate the answer, and then look into my suggestions. So area of this hexagon, I should say regular hexagon, is answer, right? Product of apothem, number of sides, and side length. Divide by 2. So A is 10 square root 3, number of sides 6, and side length is given to us as 20 centimeters. Units will be centimeters squared. We are multiplying these sides, right? N is numbers, so A and S are side lengths. Divide by 2, correct? So now it's easy to calculate. You can actually divide it by 10, and you know 10 and 10 100, 600 square root 3 centimeters square, right? So that's how you could calculate the answer. You can find decimal equivalent also. 600 times square root 3 is equal to around 139.2 centimeters square, or approximately 139 centimeters square. Is that clear to you? So it's easy to remember, and I hope you have understood the concept behind. So a regular polygon of n sides will have n triangles. To find area of a triangle, it is half base into height. That height is called the apothem. So once you know the side length, which is the base, and apothem the height, you have the area of a regular polygon. Correct? I'll provide you links for alternate methods of finding area of regular polygons. Also, we'll look into how to find area of irregular polygons. I hope the concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.